Hi everyone, myself Dr. K. Kirtiha, Associate Professor, Department of Mathematics, K.S.Rangasamy College of Technology. Today we are going to discuss about the topic on properties of eigenvalues. This properties of eigenvalues is from the course Matrices and Calculus. The properties of eigenvalues belong to the module Matrices. So the topic is properties of eigenvalues. Before we enter into this properties of eigenvalues, hope all of you should know the definition of eigenvalues. So what is eigenvalue? Eigenvalue is nothing but the roots of the characteristic equation. So here there are 5 properties. First property is sum of eigenvalues is equal to sum of main diagonal elements. Property number 2 is product of eigenvalues is equal to determinant A. The third property is if lambda 1, lambda 2 up to etc. lambda n are the eigenvalues of capital A, then the eigenvalues of the inverse of the matrix are 1 by lambda 1, 1 by lambda 2 up to etc. 1 by lambda n. Then the fourth one is same as if lambda 1 up to etc. lambda n are the eigenvalues of the matrix A, then the eigenvalues of the square matrix, that is A square, is lambda 1 square, lambda 2 square up to etc. lambda n square. The last property is for any upper triangular or lower triangular matrix, the eigenvalues are nothing but the main diagonal elements. So here we are going to discuss about some problems based on these properties of eigenvalues. The first sum is find the sum of eigenvalues of the matrix A is equal to, it is a 2 by 2 matrix, 1 2 minus 1 1. Actually this problem is based on property number 1. So here without calculating eigenvalues, we can find, using the property, we can find the sum of eigenvalues. So here first we write the given matrix. So here we highlight the main diagonal elements 1 1. So what is property number 1? Sum of eigenvalue is equal to sum of main diagonal elements. So here the main diagonal elements are 1 1. So we add 1 plus 1 is 2. So we get the result, sum of eigenvalue is 2. The second problem is the same one, the same topic, sum of eigenvalue, but here the given matrix is a 3 cross 3 matrix. So here we highlight the diagonal elements in a red color, okay. Then the sum of eigenvalue is equal to sum of main diagonal elements. So here the diagonal elements are 2, 1, 13. So 2 plus 1 plus 13 is equal to 16. Then the third problem here, if 2 and 8 are the eigenvalues of the matrix A. So before we enter into this problem, you see the given matrix. So here the matrix is a 3 cross 3. So definitely this matrix has 3 eigenvalues, but out of these 3, 2 eigenvalues are given. So using some property, we can find the third value. Solution. So here you write the given matrix A and highlight the main diagonal elements, okay. The next one we consider, because third eigenvalue is missing. So we consider lambda 1, lambda 2 and lambda 3 are the eigenvalues of the matrix. Now we are going to apply the first property. Sum of eigenvalue is equal to sum of main diagonal elements. So sum of eigenvalue, it means lambda 1 plus lambda 2 plus lambda 3 is equal to 6 plus 3 plus 3. So 2 plus 8 plus lambda 3 is equal to 12. So from this easily we can find lambda 3 is equal to 2. Then the fourth problem is product of eigenvalues. Here the given matrix is a 2 cross 2 matrix. So here by using property number 2, easily we can calculate the product of eigenvalue, because property number 2 is product of eigenvalue is equal to determinant A. So here once again you write the given matrix A, then the product of eigenvalue is determinant A. So to find product of eigenvalue, just we calculate only the determinant A. So here the determinant value is 14, that is the product of eigenvalue. Then the fifth one is find, again here also we find the same product of eigenvalue, but the only difference in the matrix, here the given matrix is a 3 cross 3 matrix. So given A is equal to, we write the matrix, again we apply the same property, product of eigenvalue is equal to determinant A. So we apply determinant for 3 by 3 matrix, so answer is 36. Sixth problem, the product of 2 eigenvalues of the matrix, 3 by 3 matrix is 16. Find the third eigenvalue. So here we are going to apply property number 2. So again you write the given matrix A. So here we consider, because product of 2 eigenvalues 16 is given, a third one is missing. So we consider lambda 1, lambda 2, lambda 3 be the eigenvalue of the given matrix. Then again we apply the second property, that is product of eigenvalue equal to determinant A. So in LHS we can write lambda 1 into lambda 2 into lambda 3 is equal to determinant A. The determinant value is 32. So product of two eigenvalue is 16. So instead of that lambda 1 into lambda 2, we replace 16. We write it as 16. So 16 into lambda 3 is equal to 32. So from this we can find lambda 3 is 2. So easily we can find the third eigenvalue is 2. So here find the sum and product of the eigenvalues. So sum of eigenvalue is nothing but the first property, product of the eigenvalue is nothing but the second property. So in this problem we are going to apply both properties. So here once again you write the given matrix, then first one, sum of eigenvalue is equal to sum of main diagonal elements, so which is equal to, so here the diagonal elements are 2, 2, 1, so just we add and we get the answer, sum of eigenvalue is 5. Then the second part is product of eigenvalues. So product of eigenvalue is determinant A, so just here we calculate, simply we calculate only the determinant, its answer is 3, so product of eigenvalue is 3. Find again here also, find the sum and product of the eigenvalue of the matrix. It is a 3 cross 3 matrix, same concept which is in the previous one. So here if the eigenvalue of the matrix A is equal to 1, 3, 3 minus 1 or 2 comma minus 1, then find the eigenvalue of A is A inverse and A square. So here to actually the given matrix is 2 cross 2, so definitely this matrix has only 2 eigenvalues. That eigenvalues are given in our problem. So using these 2 eigenvalues we calculate only the eigenvalues of A inverse and A square. Actually it is based on property third and fourth. So the eigenvalues of the matrix A inverse are 1 by lambda 1 and 1 by lambda 2. So lambda 1 is 2, lambda 2 is minus 2, so 1 by 2 and 1 by minus 2. Then the next part is the eigenvalues of the square matrix. So the eigenvalue of A square is nothing but lambda 1 square, lambda 2 square. So lambda 1 and lambda 2 are given. So square of those eigenvalues are 4 comma 4. The last problem is find the eigenvalues of the inverse of the matrix. So here just only A is given. So using this A we calculate the eigenvalue of the inverse of the matrix. So without calculating the eigenvalues, how we find the eigenvalues of inverse of the matrix? So this problem is based on the last property, property number 5. For any upper or lower triangular matrix, the eigenvalues are nothing but the main diagonal elements. So here before we start the process, we see the given problem. Here the matrix is the upper triangular matrix. So here the eigenvalues are nothing but 2, 3, 4. So 2, 3, 4 are the eigenvalues of the matrix A. So what are the eigenvalues of the inverse of the matrix? Means there is 1 by lambda 1, 1 by lambda 2 and 1 by lambda 3. So 1 by 2, 1 by 3, 1 by 4. So from this lecture all 5 properties of eigenvalues are discussed. Hope everyone should understood. Thank you.